All right, can you hear me?
Yes.
Okay, so now, just a very quick recap. Okay, so yesterday we talked about the principle of conservation of momentum. So that means I don't care what happens. Okay, I don't really care what happens, as long as there's no external force from the outside. Your momentum will always be conserved. Are you okay?
Yes.
So yesterday, the trouble that we encounter is, first and foremost, we were confused about which formula to use. So for example, in your syllabus, elastic collision is about the two objects which will be moving separately after the collision.
Mm-hmm.
And then, as for the inelastic collision, the two objects will simply stick together and then they will move together after the collision. That's why the two objects have the same velocity after the collision. So the first difficulty is we need to decide which formula to use. But to be honest with you, actually, this formula, I can tell you, is almost the same as this formula. Because for inelastic collisions, since they said that common velocity, right? So of course v1 equal to v2, then we would just simply call that v. All right. So this is the first difficulty that we encountered. The second difficulty that we encounter is, for example, we have to look at this. If they were to give us gram, I know that I shouldn't be using gram. Instead, I should have converted to kg. Okay, 10 times 1. I mean, you can write it like this: 10 times what? 1 times 10 power negative 3 kg, which is just simply 0.01 kg. All right.
Mm-hmm.
So the second difficulty is about the standard unit. Okay, the SI unit. Remember, we only use kilogram for mass. What is the SI unit that we use for length, by the way? For length.
The unit.
For length, yes, the standard unit. The standard unit for length, what is that? Is it meter, millimeter, centimeter, kilometer?
Kilometer.
Wrong. We use meter.
Kilometer.
Because you see, yesterday we did so many things about the what? Meter per second. Meter per second. Did we use kilometer per second? Did we use that?
No.
No, right? So that's why I said the standard unit is about meter. It's not kilometer, all right? But the standard unit for mass will be kilogram, not gram, all right?
Okay.
And then the last difficulty that we encounter is, okay, the very last difficulty that we encounter is we need to assign the symbols. Okay, we need to assign the variables. For example, okay, in this question, do you still remember what do we assign 1,000 kilogram? 1,000 kilogram, what do we assign it? We call that what?
M1.
Okay, continue. This one.
U2. U1.
Okay, U1, okay. This one, 800 kg.
M2.
Okay. 2.
U2.
Okay. And then this one, 3.
V2.
Okay. This one, what is the thing that we are going to find in this question?
V1.
Okay. So in this question, they were asking us for V1. So we simply list down the M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2, and then we simply plug in the values correspondingly. Are you okay?
Okay.
And now the last difficulty, okay, the last difficulty that we encounter is about the forward and backward direction. Generally, whenever your velocity is going to the right, we give you a positive sign. But when your velocity is going to the left, then we give you a negative sign. For example, let's look at this. Okay, so by the same reasoning, I hope you can help me to label which one is M1, which one is U1, which is, I don't know, whatever. Okay, let's start from this one. Help me to label, please.
M1,
Okay,
U1,
okay,
M2,
okay,
M2,
M is mass.
U2.
U2, right? U2,
Mm.
And now, can I ask you a question? What do you understand by this word? This word opposite, opposite.
Going back,
So is there any number that maybe I should, adjust a little bit?
negative,
Which one? Can you be a little bit more specific?
negative 12,
Okay, U2 is negative 12 meter per second. Are you fine?
yes,
Okay, we continue. 0.5 kg is the same thing, no? M1, no? Are you good?
yes,
Okay, this one, 14.
V1,
And also by the same reasoning, is there any adjustment that you want to make to the number?
negative
Ah,
14,
negative what?
D,
Negative 14. Why did we know that this is negative 14? Because it's going backwards. All right.
okay,
Okay, so now you can check. Seriously, seriously. Normally, I need the student help, to write down the negative sign at the beginning. That means before they even started to solve the question, they should have jotted down that the U2 is negative 12, the V1 is negative 14. Without the negative sign, later on everything will be wrong.
okay,
Okay, so yeah, we have spent the first 10 minutes to revise everything that we learned yesterday. So make sure you are able to overcome the difficulties. Now let's move on to free fall today. All right, to free fall today. I believe when you Google physics, the most famous equations, okay, the most popular equations of all time will be F equal to ma and then E equal to mc squared. Seriously, when you Google physics, the pictures that will pop up will often involve F equal to ma, E equal to mc squared. They are the most famous equations of physics. But in your syllabus, we are only going to learn F equal to ma. So can you tell me what is F? What is F? What does F stand for?
force,
Okay, if possible, can you slightly change your answer? Can you say that it is the net force?
net force,
Net force, net force. Do you know what is net force?
no,
Okay, for example, now we are doing business. Are you okay?
yes,
Let's say now we are doing business. The profit, okay, by the way, gross profit, let's say, the profit now we have is, let's say 1,000 ringgit Malaysia. However, when we do business, there will be some, some loss, some, I mean, something that we have to pay for. Okay,
okay,
maybe I need to pay for 250. Maybe okay, I need to pay for this for food, for I don't know, delivery, for transportation, whatever it is. Okay, the rental, whatever. So can you tell me what is your net profit? Net
Uh,
profit.
80, 815.
Do you mean 815 or 850 or whatever?
850. Is
Okay,
it
now
minus?
It's minus, but maybe something is wrong with your calculation. You take out your
Oh, 750. 750.
Okay, 750 lah, 750. All right. Okay,
Yes.
never mind. Never mind. It's okay. Next time we use our calculator. Okay, so what do you mean by this is when you look for net profit, you already find out the very, very, very resultant profit, right? I mean the final value already. Am I right? Net profit. So now let me ask you a question. Let's say this is on the ground, and then this is an object. Okay, maybe I should duplicate this picture. Give me a while. Give me a while.
Mm.
Okay. Can we assume that we are a box now? We are a box lying on the ground. Are you okay?
Yes.
Okay, so now there is a force. There's a force pulling you to the left. Let's say 8 Newton. 8 Newton. Oh, by the way, did you know that the unit of force is Newton?
Yes.
Okay. And then there's a force to the right. Let's say this is 3 Newton. Okay, 3 Newton. So imagine you are a box. Someone is pulling you to the left at 8 Newton and someone else is pulling you to the right at 3 Newton. So can you tell me what is your net force, please?
Five.
5 Newton. Can you tell me the direction as well?
What meaning?
Direction, to left, to right, or whatever. The net force is to which direction? Okay, actually, we follow the larger one. We follow the larger one. Who is larger here?
8.
Okay, no, we following the 8. It's to the left. Because the 8 Newton is larger, so we follow the box. Okay, we follow the leader now. Okay, we follow the leader. Because since you mentioned the 8 is larger, so we are following the direction of the 8 Newton. Are you good?
Yes.
Can I? Okay. Let me give you some more example now. Hey, surprisingly, this time they are in the same direction. That means the people here want to push you to the right at 8 Newton, and another person is also pulling you to the right at 3 Newton. So what's your net force, by the way?
11.
Can you tell me the unit as well and also the direction? Thank you.
Yeah. 11 Newton. And to the right.
Okay. So you understand or not? You understand or not? The net force, is the resultant force that you have already taken into consideration of the what of all the individual components of forces. Are you good?
Yes.
That means when you already look at the general picture, when you already calculated all the individual components of forces, then you tell me, the net force is blah 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 blah, and to which direction? All right.
Yes.
Okay. One more example. One more example for you. Okay, sorry, just now I forgot to tell you about this. Hang on. Okay, now you look at this. When we draw something, right, the shorter the arrow, it means that the value of the force is smaller. For example, you see this 1 Newton. Wow, the arrow is so short. Wow, you see this 8 Newton. Wow, so long, because it's 8 Newton, right? the larger the value, the longer the arrow. Are you good?
Yes.
So sorry, just now I forgot to tell you about it. So I should have drawn this line to be very, very long. Okay. I mean, the longer the line, the longer the arrow, then the larger the magnitude. Are you fine?
Yes.
Okay, so now can you tell me what is your net force here? Thank you.
Uh, how to find this?
How to find? Then you sum up all the forces to the, I don't know, to the right, and then minus all the forces going to the left. Something like that. Would you like to guess, or maybe you need help?
Is it 4?
No, no. Okay, you look at this. 3 and 5 are going to the left. Agree?
Mm-hmm.
So everything here is 8 Newton, no? Am I right?
Yes.
And then here, 8 plus 1, no? So it's 9 Newton, right?
Mm-hmm.
8 and 9, they are opposite, right? They want to kill each other. Okay?
Mm-hmm.
I repeat, 8 Newton going to the left, 9 Newton going to the right. So in total, what do you think is the resultant force?
1.
Okay, 1 Newton. Yes, direction, please.
To the right.
Okay. Okay, so now you understand, in order to get the net force, oh, by the way, I forgot to tell you again, oh, so sorry. Net force is known as resultant force. They are the same, okay? They are synonyms. All right. Just like later on when you learn about the moment, torque, turning effect, actually they are the same thing. They're just synonyms, all right?
Okay.
So sometimes if I'm lazy, I will just simply say that this is F and then net here. It means net force, no? Are you good? Net force.
Yes.
Okay, now let me give you one more example, just one more example. Okay, can you give me some lucky numbers now?
4.
Okay, give me a lucky number between 0 and 10. Okay, two more numbers.
9.
9. Okay, one more force.
2.
2. 2, maybe here. Okay. Mhm.
Is it 7?
Okay. Yes, tell me. What about the unit? What about the
7
direction?
newtons. And to the right.
All right. So for today, the first thing that you learn today is how to find the net force. All right. So now coming back here. Can I have a small request from you? Next time when I ask you F equal to ma, to be honest, instead of telling me force, I will appreciate if you can tell me actually that is already the net force. Okay. So I repeat, I mean, it's not wrong. It is not wrong. When I ask you what about the F, you can tell me about force, but I will appreciate even more if you could tell me that is net force, or you can tell me that's resultant force. Are you good?
Yes.
Okay, so tell me what is M? M, is it McDonald?
Mass.
Mass. What is A? Small letter A?
Acceleration.
Okay, now can you think of the corresponding unit? For example, what is the unit of force just now?
Newton.
Okay, what is the unit for mass?
Kg.
Okay, What is the unit for acceleration?
Uh,
Mhm.
not sure.
Oh no, meter per second square. Okay, hang on. I think I need to remind you a bit about this. Do you still remember last time actually we learned about the what? The distance time graph and then the what? The speed time graph, huh? Agree, eh?
Yeah.
Okay, let me ask you, what is the unit for distance, please? Unit, unit.
Okay.
KM? No, we are not going to use kilometer.
So this
Meter now, meter. Are you okay?
unit is meter.
Mm-mm. Okay, now actually it's very easy to think like this. Actually, it's very easy to think like this. Now you are doing some experiment in your lab, right?
Mm-hmm.
Is it even possible that we can go for a distance of 1 kilometer in a lab?
No.
No, right? I mean, it's funny, right? Hi guys, today you are in the laboratory, and then I hope that you can do an experiment such that maybe I don't know, the toy car can run for 1 kilometer. How can it be possible? 1 kilometer length, you know? Okay,
Yes.
okay, okay. Displacement.
Meter.
Mm-mm. Okay, I think actually, to be honest, to be fair, actually sometimes I can understand I can understand a student's confusion actually, because for
Mm.
length we use meter, but for mass, we use kg. Whoa. You know, for mass we have kilogram, but for
Mm-hmm.
length we use meter only. We don't even use kilometer. All right.
Yes.
What I can say is just memorize lah. Okay, just memorize them. All right.
Okay.
Okay. So for example, when people ask you what is your body mass, you will answer me like 45 kilogram. That means you are unconsciously using kilogram, right?
Mm.
Then okay lah, use kilogram lah. All right. Just like the people asking us like how tall you are. Oh, 1.8 meter. We subconsciously we use meter, you know. All right.
Okay.
Okay. Okay, now let me ask you, can you give me the unit for speed and velocity? Thank you.
Speed is meter per second.
How do I write down meter per second?
MS. Uh,
MS what? I'm following you. MS what? How do I write down meter per second? There are two methods actually. There are two methods.
-1.
Okay. MS power -1. Another will be M/S. No? Are you good?
Yes.
I'm fine with either one. I am totally fine with either one. Okay, what about the unit for velocity?
See?
Same, no? Same. Okay, same. Very good. Now, can you tell me what about acceleration?
Meter per second.
That's it?
Uh, -2.
Okay, then actually you should say meter per second square. I repeat,
Oh,
meter per second square. Meter per second square. Are you good?
yes.
Okay, so can I give you like, I don't know, 5 seconds or 10 seconds? Make sure you understand all the units, right?
Okay.
Just tell me if I can move on.
Okay. Okay.
Can I? Okay, let's come back here. Okay, now I need you to remember that actually, 1 Newton is 1 kg times meter times per second square. All right.
Mm-hmm.
I repeat, Newton equal to kilogram meter per second square. Are you good?
Yes.
Now, can you imagine that now we are in a free fall today, and then in a free fall, I want you to remember that today we have no air resistance. Can you imagine that now we are living in a world where we have no atmosphere? That means we have no air molecules around us. Imagine now we have got no air molecules around us. Are you good?
Yes.
Okay, so today, help me to remember that no air resistance. You don't have air molecules around you. You don't have to breathe. You have no air resistance, so you have no air friction, air drag, or whatever. Oh, by the way, did you know that air drag, air friction, air resistance, they are the same? Help me to remember, no such thing here. Okay? But later on, I will introduce this to you back again, all right? Later on. Let's say after 20 minutes, okay? So now, can you imagine that now you are holding a ball and then now you are standing at the edge of the very tall building? Help me to remember that the ball is like a very, very heavy ball, like a very heavy tennis ball, right? Tennis ball, let's say, all right? Now, you drop the ball. Notice the word drop. I can say that you release the ball, you let go of the ball, you release the ball, you drop the ball. When you see this kind of wordings, you need to highlight this. It means your initial velocity must be 0. I repeat, when you see the word drop, release, let it go, whatever, initial velocity must be 0. Are you fine?
Yes.
Okay, now, actually it's like this. Before the year of, I forgot 2022 or whatever, before the year of 2022, we simply tell the student that A equal to 10 meter per second square. Are you okay? This is our gravitational acceleration. Okay. So after the year of 2022, we start to tell students that okay, fine, life is not that perfect. You don't have such a lovely number with you, so we better use 9.8. Are you okay?
Yes.
And of course, later on, when you are interested to further your study in physics, we will use the word the number 9.81. So today, right now, we use A equal to 10 first. Are you good?
Yes.
What do you understand by the acceleration is equal to 10 meter per second square? It means after each second, your velocity is going to increase by 10 meter per second. This is what it means. I repeat, if anyone asks you, what do you mean by acceleration is 10 meter per second square? Then your response is, well, what do I understand about A equal to 10 meter per second square is per each second, my velocity is going to increase by 10 meter per second. Okay. For example, at 0 second, my initial velocity is 0. After 1 second, 10 meter per second. After 1 second again, it becomes 20 meter per second and so on. Are you good? Can I?
Yes.
Of course. If the student really wants to prove that all the acceleration is the same, then they can look at this. Okay. Still remember, in the first second, you go from 0 to 10, right? So that's why your acceleration is 10, no? From the first second to the second second, then your velocity increases from 10 to 20. So no wonder your acceleration is still 10. And finally, from the second to the third second, your velocity is from 20 to 30. So no wonder it's still 10 meter per second square. So that's why I'm going to say that gravitational acceleration is 10 meter per second square. Are you fine?
Yes.
But now, like I said, we need to change a bit the number lah. We need to change a bit the number. So maybe starting from now, can you say that this is, let's say, 9.8? After 1 second, the V is 9.8 meter per second. Are you good?
Yes.
Can you help me to check the value when this is second? What's the velocity when this is the second?
19.6.
Very good. After 3 seconds?
29.4.
Okay. Very good. So understand, understand. At least for your batch, you should be using A is 9.8 meter per second square. All right. But having said that, when you read any reference book or whatever books, if you found out they are using 10, don't blame me. It's because before the year of 2022, at least for IGCSE students, they are using 10. All right. But never mind, you are going to know what is the number that you are going to use at the front page of your exam paper. They will tell you, in this exam paper, use G equal to 9.8 meter per second square. Something like that, right?
Okay.
Okay. Now, imagine now you are throwing a ball. I'm holding a ball and I'm throwing the ball up to the sky. I want to throw it into the sky. The moment when I throw it upwards, wow, it's so fast, right? After a second, I believe it will slow down a bit, right?
Yes.
Because when you are going up, it should slow down. And then when it is coming back, when it is falling down, then the velocity will be faster and faster. Are you okay?
Yes.
So do you understand that why this is like 30, 20, 10, and 0? 0 is at the highest point. I repeat. At the highest point, you should tell me that the vertical velocity will be 0 for sure. I repeat. At the highest point, your vertical velocity must be 0 for sure. Are you good?
Yes.
If it's not 0, you can find me. Okay. 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 So now, so can you help me to remember that in the upward motion, when you throw the ball upwards, actually the ball is slowing down. Because you go from 30, and then 20, and then 10, and then 0. Am I right? That means you are getting slower and slower during the upward motion. You are getting slower and slower. Are you good?
Yes.
Now, let's talk about the falling down motion. Wow, from 0 becomes -10. Huh? Negative 10? Why did I put a negative sign for this velocity? Why? Why? Why I said that the velocity is negative? It's so weird to give it a negative sign. Why is it so?
Going down.
Because you are going down. So that's why we give the number a negative value. All right?
Okay.
Okay, so can I say that downward motion is something that you are getting faster and faster and faster? All right? Okay, understand?
Yes.
Okay, so now, this is the very, very, very typical experiment. Very, very typical experiment in physics. Now, can you imagine that the ball, like I said, the ball is a very heavy ball, right? The reason why I want to mention this is because I don't want students to imagine that the ball is very light, just like a ping pong ball. just like a table tennis.
Mm-hmm.
Not the very light ball, but a heavy ball. All right. Even if you say that this is the ball that you want to play in the what? In the bowling, bowling, the very big, heavy one. Also can. Okay. The bowling,
Okay.
the bowling one. Okay. The very heavy one. Okay.
Okay.
And feather. Obviously, feather is something very light. Are you okay?
Yeah.
So now, okay, you imagine now you are holding one feather, a piece of feather, and you are also holding another very, very heavy ball, and then you are going to let them go. You simply release them. You simply release them. Okay, remember, I used the word drop. I didn't use the word throw, like, throw. It throw means you are going to throw something downwards. You throw it. But drop means you let it go. No? You let it go very gently. Let it go. Just simply let it go. You don't even throw it, All right.
Mm-hmm.
Okay, so can you tell me? Now you have two options. You can tell me the result in the air, or you can tell me the result in vacuum. Are you okay?
Okay.
Which one you want to start with? In the air or in the vacuum first?
Air.
Okay, air lah. In the air, which one of them, feather or the very heavy ball, which one of them do you think it will touch the ground first?
The ball.
Okay. So now, you told me that the ball will hit the ground first. Hit the ground first. Are you okay?
Yes.
What happens in vacuum?
Ball also.
That means ball also will hit the ground first now compared to the feather. Am I right? And the answer is both hit the ground together. Okay, I repeat. In the air, the ball is going to hit the ground first, but in vacuum, actually both of them will reach the ground together. Are you okay?
Okay.
So now, you read the result first. Later on, I will explain to you why.
Okay.
Of course, later on after the class, if you have some free time, you can go to YouTube or whatever. You search for this. It's a very fun experiment. Of course, you have to be very rich to do this experiment. They actually use the what, They actually use the, how do I say? Is it air sucker or what? I don't know. There's a huge building, they simply suck out all the air molecules. They really throw a bowling ball and a feather, and it really shows that they really fall down at the same speed and then hit the ground together. I mean, it really happens, all right?
Okay.
Okay. Right. I mean, if you are curious later on, you look for the YouTube video. Okay.
Okay.
Okay. So now, are you happy with the results?
Yes.
Are you happy with the outcome? Okay. Now, right now, as I'm talking to you, now is about 2:40 in the afternoon. So hot, right? I need some fan, right? We enjoy the wind, right? The wind makes us very cool, right? Do you know what is the so-called wind? Wind, the wind flowing, passing through your face. The wind is actually the so-called air friction, air resistance, air drag. Are you okay?
Yes.
I repeat. I need your help to remember that the wind that passes through your face, that blows through your face, is exactly the air friction, the air resistance, and the air drag. And for your information, they are the same. Yeah. So later on, you don't have to ask me what's the difference between friction and resistance and drag. They are the same, right?
Thank you.
Now, can I ask you to imagine that? Okay. Can I ask you to imagine that? Now, you are standing still. Sorry. And now, can you imagine that there's no natural wind around us? No wind. I mean, you don't expect the wind that comes to you naturally. Okay. Actually, have you ever been to some big city, like, I don't know, like to Singapore or whatever?
No.
Oh, never mind. Because sometimes when you are in Singapore, you will realize that actually sometimes like you couldn't feel the wind, even though you are standing outside the shopping mall or whatever. It's because they have so many the skyscrapers that actually block the natural wind. Okay, so you basically feel like, hey, how come there's no natural wind around me? Okay.
Yes.
Okay. Anyway, let's come back here. So imagine now you don't have any wind that comes from nature. So when you are standing still, that means when you are not moving, then you didn't feel any air blowing through your face, right? So I can say that you didn't have any air frictional force. Are you okay?
Yes.
If you want to feel the wind, then what you should be doing is you need to run. You need to run as quickly as possible. Because the higher the speed, the faster you run, the greater the wind blowing through your face. Am I right?
Yes.
Okay, so the first thing I want you to notice today is actually air friction depends on what you know. Air friction depends on your motion. It depends on your speed. If you are very slow, then your air friction is very slow. It's very small. But if you are very fast, if you move very fast, then your air friction is very, very, very high. Do you agree?
Yes.
So now, okay, hang on. Before I proceed, I need to remind you, you see the name of this document or not? It's called free fall, right? Free fall. Then just now, when I talk about everything in vacuum, when I talk about everything in vacuum, then only this is known as free fall. Are you okay?
Yes.
Because in vacuum, the only force acting onto the object is the gravity. I repeat, in vacuum, the only force acting on the object, acting onto the falling object is the gravity. So that's why let's look at the ball. The weight is pulling the ball down. Did you know that the weight is W equal to mg? Let me test your understanding. W equal to mg, right?
Yes.
What is W? What do you call it?
Weight.
Very clever. M.
Mass.
Okay. What about G? There are two meanings of small letter G. What is that?
Gram.
Huh? Gram? Gram? You use gram only when they match a number with G, man. Like let's say the mass of this calculator is, I don't know, 200 G. Then 200 gram lor, because you have a number with the G, right? So when you have a number with G, then we call the G as a unit of gram. But this one, G is not the same lay. In fact, I can tell you the G here is 9.8, But what do you call G? What do you call G? Does it have a name? The small letter G? Dun, 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 dun. Gravitational what? Gravitational something. It starts from A. Gravitational acceleration. All right. Can I? Gravitational acceleration. Okay, when this is gravitational acceleration, we call that G equal to 9.81 meter per second squared. There's actually another meaning. We call that gravitational field strength. Are you okay?
Yes.
For gravitational field strength, actually the definition is something like force per unit mass. So that's why this is G equal to 9.81 Newton per kg, because there is force per mass. I repeat, I need your help to remember that the small letter G is known as gravitational acceleration and also gravitational field strength. Am I right? Okay, so this is W equal to mg. And do you know meter per second square and Newton per kilogram, it seems like they are not the same unit, right? You look at unit, meter per second square and Newton per kg. It seems like they are not the same, right?
Yes.
But actually, they are the same, because according to F equal to ma, Newton equal to kg times meter per second square, right? So mathematics, I move the kilogram to the other side. So they are the same. Then you look at the green, the yellow one. The yellow one you check. Can meter per second square and Newton per kg, actually they are the same. Oh my goodness, surprisingly they are the same.
Yeah, wait, my dad call me.
Sure, come.
Okay.
Okay, welcome back. Give me a second. Okay, welcome back. So now, okay. So, okay, notice in the vacuum situation, I said that this is a free fall. Because the only force acting onto the ball is gravitational force. By the way, weight is known as gravitational force. Gravitational force is weight, and then weight is gravitational force. They are the same. Are you good?
Okay.
I do not really appreciate when the student tell me the small letter G is the gravitational force, because that's not. I repeat, I do not want the student to tell me small letter G is gravitational force, because that's not. All right, that is the gravitational acceleration. That is the gravitational field strength. You get me?
Okay.
Okay, so can I move on? Remember, I only said that the motion in vacuum is free fall. In the air, please do not even call that free fall. I repeat, in the air, don't ever call that free fall, because we have some extra force here. Would you like to guess what is the extra force in this case? Apart from gravitational force, is there any other force acting onto the ball in the air while the ball is falling down? What are the extra force? What is the extra force, or what are the extra forces acting onto the ball when it's falling down in the air? Something that you learned just now. There's a wind passing through your face, and what do you call that force?
No air.
Huh? Air friction force.
Oh.
That one is known as air frictional force, because when something is dropping, or first thing you tell me there's a weight pulling it down, and then you tell me there is a what? There is an air frictional force. For your information, the air frictional force will always oppose your motion. So if you want to go to right, then the frictional force will be going to the left. If you want to go downwards, then the frictional force is upwards. Whatever you do, the air friction or the air resistance will always oppose your motion. Okay?
Okay.
I repeat, wherever you go, the air friction will be like pulling you back. They are like the opposition party, they are like the opposition party. Whatever you do, they will just oppose, and they will just say no. All right?
Okay.
Okay. So now, okay, so do you still remember just now the concept that we have is the faster you are moving, then the larger the frictional force. Do you agree?
Yes.
Because the faster you run, the greater the wind blowing through your face. Agree, eh? So now we have this. Okay, at least now we understand that the higher the velocity, the larger friction. So I can say that air friction force is directly proportional to the speed. Okay, hang on. Do you still remember that V can stand for either speed or velocity?
Yes.
Do you know why? Why I have to stress about this is because I don't want student to tell me that S equal to speed, Because distance, we can use S. Displacement, we also can use small letter s. Are you think?
Yes.
The very common mistake is they are trying to tell me that, oh, teacher, you see, S, you see speed, speed, the starting alphabet, the starting letter is S. So why don't you use S to, to represent speed? Well, we don't do that, right?
Okay.
Okay, by the way, this one, how do you call it? This one, this symbol, it looks weird. What is this guy? We call it directly proportional. Are you okay? The air frictional force is directly proportional to speed. Are you okay?
Yes.
Okay, if you trust me, in your syllabus, normally we say that F equal to kV lah. The F is air frictional force. Okay, look at this K, K. In physics, whenever you see a small letter K, do you know what does that mean? It means something constant. Are you good?
Yes.
Did you know why? You see, constant, 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 you know?
Mhm.
It starts from K, right? Constant, constant, right? Constant, K. So no wonder we are using small letter K to denote something constant, all right?
Okay.
Meaning that K is just a number, lah, okay? K is just a constant number, all right? And then V is the speed, law. Because we understand that not every student will have a very strong foundation in math. So to be honest with you, we can actually make our lives harder. We said that, okay, F frictional force is equal to K times V squared. Okay, if we want to make our life even more difficult, we can just tell them that V, like maybe 2/3, no? Maybe now you are trying to question me, like, how did you know that which power is correct, by the way? The answer is I also don't know. Because air frictional force depends on your surrounding. It depends on what kind of air molecules do you have. It depends on the humidity of the air. It depends on the shape of the object. Because different shapes will have different air resistance, right? Just like a sport car, you know, a sports car. A sports car have aerodynamic shape. A big truck has, a big truck will have more frictional force. No? So that is why, personally, I cannot tell you which power in reality, because we really have to do the experiment. Then only we can know the power of the velocity. But at least now we are in IGCSE, right? So okay lah, okay, let's make our life easier. Just use F equal to kV. Are you okay? So that's why I'm going to say that this is more common. Are you fine?
Yes.
Okay, so at least today, you already learned the formula for weight just now, right? Do you still remember W equal to mg, the weight? W equal to mg, do you still remember?
Yes.
And now, this is F equal to kV, are you okay?
Yes.
So that is why I need your help to remember today, F equal to kV and W equal to mg. Those are the two formulas that I really need your help to remember now. If not, we cannot move on. All right.
Okay.
Okay, so I repeat that. Today you learn about frictional force and then you learn about weight, which is the gravitational force. Are you okay?
Yes.
I think maybe it's going to rain soon. Maybe, I don't know. When it's raining, there are a lot of water droplets coming down from the sky, right?
Yes.
Can you imagine that? Is it possible, is it possible, the water droplets falling down can kill you? For example, if something is falling down from the sky, if it hits me, I think I'm gone, right? I mean, let's say there's something like, let's say one calculator, one calculator falling from the sky. When it hits me, I think I'm gone. I don't have to work anymore. All right. But do you think the same thing will happen when I go out during rainy days? Because the water droplets will also be falling down onto my body, right? So will it kill me just like a bullet, piercing through my body? And why? Why the water droplets cannot kill you? Why they are so gentlemen? And they are not aggressive, they are not very fierce. They are not violent to kill you directly. Why?
Too small.
Too small. A bullet is also very small one. Can you imagine it? Bam! A bullet is also very small, right? But it still kill you. A bullet. Never mind. Okay, so let me ask you a question. Now, remember, this is in the air. Are you okay?
Yes.
This is in the air. When you let go something from the sky, initially the velocity is 0. And then I said that after 1 second, it becomes 10 meter per second. After 2 seconds, it becomes 20 meter per second. So after a very, very, very long time, is it possible that the velocity, wow, will become such a high value? Is it possible that the velocity can achieve such a high value?
Yes.
So that means that when the falling time becomes infinitely long, when the falling time is infinitely long, then the falling down velocity will be very, 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 very high. Do you agree?
Yeah.
The answer is in the air. Notice that I said that this is in the air, in the air. That means that I'm now talking about situation happening on the lovely earth. Okay. The answer is this one is impossible. It cannot happen. All right.
Okay.
I agree that when you are falling down, your velocity will be increasing. But I do not agree that your velocity will be increasing up to infinity. Are you good?
Yes.
Just like when you go to work later on, okay, when you go to work, maybe the first month you are working, your boss offer you, let's say, your salary this month is 3,500 ringgit Malaysia. Are you good?
Yes.
After each year, we expect to get a pay rise, right? I mean, of course, the salary should increase a bit over the years, right? But is it true that when you are working till you're old, wow, then your salary is so high, like let's say 80,000 per month? Is it possible?
No.
Cannot, right? That means you agree that actually you will have some pay rise in your salary, but they won't get to a super crazily huge number. Am I right?
Yeah.
Okay, so this is what happens today. I agree that your velocity will increase when you're falling down. I agree. But I do not think that your velocity will increase up to infinity. Are you good?
Yes.
So now let's try to talk about this. This is exactly what happens in the reality. Initially, when you are just happen to fall down, right? That means initially when the water droplet is falling down from the clouds. Are you okay?
Yes.
I mean, this is the case where the water is still at the cloud there. They start to form a water droplet and then they start to fall down. All right?
Yes.
During the falling down motion, wow, your velocity will increase, but you will increase up to a certain value, then you will stop increasing. Are you okay?
Yes.
So now, can you help me to remember this shape? Remember, this is a velocity time graph. And this is a velocity time graph. And then the shape should look something like this. Help me to remember. All right.
Okay.
One more thing for you to remember is for the largest speed, we call that Vt. T means terminal velocity. Are you good?
Yeah.
So if people ask you, what is the largest speed achievable by a falling object? Then your answer will be terminal speed. Are you good?
Yeah.
Have you ever heard of the word terminal before? Terminal.
No.
Or terminal bus station. Have you ever heard of that? Terminal bus station. Terminal. Okay, never mind. Let's say I'm now taking a bus. Are you okay?
Yeah.
I'm now taking a bus, a public transport, a bus. When the bus passes through a station, actually some passengers will get up, some passengers will get off the bus. let's say I'm the one who loves traveling in a bus, because I know that the bus fare is quite cheap, right? So if I've got nothing to do, then I'll just sit in the bus, seeing where the bus can take me. So after we pass through each station, actually the bus driver will not chase me down because they're just normal bus stations. But when we finally arrived at the terminal bus station, then the bus driver will tell me, okay, sorry, you all have to get down now because this is already the terminal bus station.
Oh,
Right?
okay.
Terminal. In Mandarin, we call it 终站. 你来到最终极了 the very final stage already. That means when you arrive at the terminal bus station, you like it or not, you have to get down the bus. You cannot keep on sitting in the bus anymore. All right.
Okay.
Okay. So terminal velocity in this case is you have already reached the terminal stage already reached the final stage already. You cannot increase your velocity anymore. Okay.
Okay.
Okay. So now, okay. Remember, how many to remember this? How many to remember this picture? Can you?
Yes.
Okay, now okay, still remember W equal to mg. Are you fine?
Yes.
What is W?
Wait.
Is the weight same as gravitational force?
No.
Weight is
Yes.
the gravitational force. Okay, gravitational force is weight. Weight is gravitational force. They are the same thing. Are you happy?
Yes.
What is small letter g?
Gravitational acceleration.
Okay, gravitational acceleration. Apart from gravitational acceleration, does it carry another meaning?
Yes.
What is that?
Gravitational field strength.
Okay, very clever. All right. Okay, W equal to mg. Are you happy?
Yes.
This one, F equal to kV. F frictional force equal to a constant times the velocity. If you are not happy with the word velocity, at least you can use speed here. Also can.
Okay.
Okay, now let's go back to the graph. Can I choose 3 lovely colors now? Let me check what color should I be using. Okay. Can I use orange color at the beginning? Can I? Orange color.
Yes.
And then the blue color in between. Can I?
Yes.
And then final stage, which color? Green. Green. And maybe pink. Pink. Are you okay? Pink. Okay. Please help me to remember. We use orange color for the beginning. We use blue color for something in between. And then we use pink color to represent the final stage. Are you good? Okay, let's get started. At the beginning, when the raindrops are just newly formed at the clouds there, so when you just happen to drop the ball, the orange color, at that moment your velocity is 0, right? Because you haven't started to fall down, right? You are just about to start to fall. So can I say that your gravitational force is simply 0? Can I? No frictional force at the beginning. Are you happy? But you still have W equal to mg with you. Are you happy? And just now, if you still remember, I mentioned that the weight must be pulling you down and then the frictional force must be going up, right? Why the frictional force must be going up? Because your motion is downwards, so they must oppose your motion, all right?
Okay.
Okay, so this is the orange color, orange color, which is this one. Okay, orange color, when you're just about to drop it. Are you fine?
Yes.
Okay, let's use the blue color. Are you okay?
Yes.
Okay, as time increases, your velocity increases. Okay, and then when your velocity increases, your frictional force will also increase. But at the same time, your weight is a constant. Okay, you try to imagine, as time passes by, your velocity actually increase. And then when your velocity increases, your frictional force will also increase correspondingly. And throughout the journey, your weight is still a constant. Are you happy?
Yes.
Finally, okay, we reach the pink color part. Are you okay? Pink color. That means until a certain time already, your velocity is already a maximum. Why your velocity is maximum? Because you have reached the terminal velocity. Do you still remember the terminal velocity? All right. When your velocity is already a maximum, then your frictional force will be maximum. Are you okay?
Yes.
But throughout the journey, your weight is still the same. Are you happy?
Yes.
Because your mass is the same, right? So your weight is still the same. And then when your velocity is maximum, we call that terminal velocity. And just now, if you still remember, when the velocity is maximum, we say that the frictional force is a maximum, right? The maximum frictional force, the maximum frictional force is actually equal to weight. That means the upward frictional force and the downward air frictional force. The upward air frictional force and the downward weight, they finally balance each other. They finally balance, they finally cancel out each other perfectly. All right.
Okay.
So this happens in the pink color region. So remember, in the pink color region, your net force is 0 because your frictional force is equal to the weight, so your net force is 0. When your net force is equal to 0, what other quantity must be 0 for sure? When your net force is 0, which quantity must be 0 for sure?
A.
Acceleration. Are you happy? When your net force is 0, obviously your acceleration is 0. Are you good? So when acceleration is 0, okay, let me test you. What is the definition of acceleration? What is the definition of acceleration?
Velocity do not change.
No. I'm asking you for definition. Definition. Do you still remember? Definition. What is that? You can tell me acceleration is actually rate of, tell me rate of what? If you still remember, what is acceleration? The rate of?
The speed change.
Okay, almost there. Rate of
The
change
velocity change. The time.
Actually, when I use the word RATE, rate, the word rate already implies something is going to be divided by time. I repeat, the word rate, RATE, already means something is going to be divided by time. Are you okay?
Yes.
Yeah, so, okay, to be fair, you can tell me acceleration is rate of change of velocity, or you can tell me acceleration is change in velocity divided by time. All right?
Okay.
Okay, so what? Repeat one more time. What is acceleration? What is the definition of acceleration?
Rate for the change for velocity.
Okay, rate of change of velocity. Okay, when acceleration is zero, what happens is your velocity does not change anymore. Are you okay?
Yeah.
So remember, this is for the pink color region, if you still remember. Okay.
Okay.
Okay, so let's get our story clear. This is like a plot. Do you still remember this one? The orange part, orange part. When you happen to drop the ball, your velocity is zero, your frictional force is zero, and then your weight is just mg. This is for the orange. Are you okay? Orange. Okay. I label orange. This one. Nah. Okay. I label here. Okay. Can I? This one. Can I? Can I? And then for blue, which is somewhere in between here, the blue one, this is here. As time passes by, your velocity increases. So that's why your frictional force also increases. But at the same time, your weight is still the same. This is for the blue one. Are you happy?
Yes.
Finally, for the pink one, wow, a lot of things. For the pink one, you notice wow, so much. I give you maybe 15 seconds. 15 seconds. Pink color, pink color.
Okay.
Can I? So for the pink color, your velocity is already a maximum. So that is why your frictional force is a maximum. And when your frictional force is a maximum, actually, the frictional force has the same value as your weight. Okay, I repeat. When your frictional force is maximum, actually it should have the same magnitude as your weight. So that's why they finally cancel each other. They finally cancel each other. Are you okay?
Okay.
So in the pink color, at the pink color there, your net force will be equal to what value? In the pink color, what is the value of your net force? Mm, mm, mm.
F.
I know. What is the value of your net force? Value. I want the number.
Zero.
Zero. Remember, at the pink color stage, when you arrive at terminal velocity, your net force is zero. Okay? If your net force is zero, then what will happen?
The A also zero.
A0 meaning that will your velocity change again?
Yes. No.
Remember, A equal to zero, that means your velocity is not going to change anymore. Because acceleration is the rate of change of velocity, right? So if your acceleration is zero, that means your velocity will no longer change. It will no longer change.
Okay.
Can I? Okay.
Yes.
So actually, I find this interesting. This is like a what? This is like a drama, what happens at the beginning of the movie? What happens in between, like that the actor kills someone or whatever. I don't know how the story plot is going to unfold. And then finally, the pink one is your final stage. Ever since they live happily, something like that. Okay.
Okay.
So throughout the journey, your velocity is increasing until it cannot increase anymore. I repeat, overall, your velocity is increasing from zero until it cannot increase anymore. Do you agree?
Yes.
Okay. Now, I give you 10 seconds. Help me to read through this. For your information, the initial is the orange color now. The orange color, still remember? The orange color for the initial stage. The pink color is for the final stage. If you still remember, we use pink, right?
Yes.
This one. Okay. Now, I give you 10 seconds. Have a look at this. Okay, you read through the orange one, then I will start to explain.
Okay.
For the orange one, at that moment, you haven't started moving, right? Do you still agree? I mean, do you
Yes.
still remember that
Yeah.
moment you haven't started moving? So that is why, can I draw an arrow here? Can I? Can I draw
Yes.
an arrow here? Cannot. I cannot draw an arrow here because no air frictional force, no such thing. All right. You get me or not? I mean, I cannot draw an arrow here to represent the air frictional force in this case because the air frictional force is 0. So I couldn't even draw the arrow. You get me?
Yes.
I can only draw the arrow for W, which is the weight. Okay?
Okay.
So do you still remember F equal to ma? Just now when I introduce you to F equal to ma, what do I expect you to tell me about the F?
Net force.
Net force. Okay, if possible, don't just tell me force. Please tell me this is a net force. This is a resultant force. So the resultant force will be weight minus the air frictional force. And then air frictional force is 0, man. So I put down minus 0. So mg equal to ma. So can I cancel the m?
Yes.
Mathematically, I can cancel them. So that's why acceleration at that moment is equal to g. Are you okay?
Yes.
That is why when I come back here, do you still remember? Okay, this is the velocity time graph, right? I'm going to write down something. I hope you can remember. One word. One word. Can you help me to fill in the blank? What does gradient of VT graph tell you? What does area under VT graph tell you? Gradient of VT graph is what?
Is 0.
No. You should give me one English word to tell me the
Oh.
quantity. For example, gradient of VT graph, I can tell you like this, acceleration. Are you okay? I still remember or not, in our very first class, when I teach you about the motion graph, I will put 3 star there. I said that this is the most important sentence. Later on, I will keep on asking you until you get numb, Gradient of VT graph is acceleration. Are you happy?
Yes.
You tell me, what is acceleration under VT graph? Okay, displacement. Okay, help me to remember. Thank you. This is very important. Gradient of distance time graph is what?
Speed.
Okay. Help me to jot down this. Last time, if you still remember, I put 3 star because I said that this is the most important formula that you should remember until forever, right?
Okay.
Can I? But today we only talk about velocity time graph, okay? We didn't even talk about displacement time graph just now, all right? Okay, so come back here. Just now we agreed that initially your acceleration is equal to 9.81. In fact, I should just tell you 9.8. So that is why when you get me the gradient here, when you get me the gradient initially, the gradient is 9.8. Are you happy?
Yes.
The gradient, I'm talking about the gradient, the slope. Okay, the slope or the gradient. Okay.
Yes.
Finally, what you can tell me about this slope? What about this one, the pink one?
The name,
Does it even have, I mean, what is the value of gradient here? Or what is the value of acceleration here?
the final, the
Mhm,
the
mhm.
the maximum for velocity.
Huh? I'm asking you what is the value of the acceleration at this stage? What is the value of acceleration at this stage? At the pink color stage, what is the value of acceleration?
Zero.
Zero. Okay. Okay. Can I understand?
Yeah.
I hope the student understand that the acceleration will go from 9.8 all the way to 0. Are you okay?
Yes.
So in between, of course, your acceleration has the value between from, I mean, it will decrease from 9.8 all the way to 0 for acceleration. Are you happy?
Yes.
So actually the thing is like this, throughout the journey, your velocity increases, but your acceleration decreases. Do you agree? I mean, throughout the journey, if you notice, velocity increases, but your acceleration decreases. You check, your velocity increases from 0 to terminal velocity, because you are getting faster and faster, so your velocity is increasing. But your acceleration will go from 9.8 all the way to 0, because to be honest, some students cannot accept this, because they will try to tell me, wow, teacher, you see, how can it be possible that the velocity increases when the acceleration decreases? Actually, it's possible. Because when I said that acceleration decreases, at least you still have acceleration, am I right? For example, let's say if you are my worker, I tell you, okay, your salary will increase. Your salary will increase. That's a good piece of information, right? Your salary will increase over the years. But the rate of increase of your salary will decrease. That means maybe in the first year you increase by 500. Wow. In the second year you increase by 300. In the next year you increase by 200. In the next year you increase by 100. In the next year you increase by 50. In the next year you increase by 40. Something like that. All right. You get the idea. Your velocity will increase, but your acceleration will decrease.
Okay.
Your salary will increase, but the rate of increase of salary will decrease.
Okay.
Okay, I understand that this is quite confusing, right? So later you can download the recording and check it again. Okay.
Okay.
Okay, so now have a look at this. Okay, hopefully you still understand us. You still remember what's going on in the pink color there. In the pink color there, your frictional force is already maximum, and then the frictional force will exactly balance the weight. So that's why your net force is simply 0. And then when your net force is 0, your acceleration is 0.
Okay.
Okay, now I have some characters for you. Let's look at the red color, the dark red. Throughout the journey, will your weight be increasing or decreasing? Throughout your journey. Throughout the journey, will the weight be increasing or decreasing?
Decrease. Which
You
one?
look at the red color, dark red. The weight will be what?
Constant.
Because your mass does not increase, neither does your mass decrease, right? So can you help me to remember that throughout the journey, your weight is the same?
Okay.
Let's move on to the orange color. Orange color. What is that? Your frictional force will increase from 0 to a maximum value, right? What is the maximum value of your frictional force? Which is the same as weight, I think. Weight.
Yeah.
Your frictional force will increase all the way so that it can balance weight. Okay.
Okay.
That means you realize or not, throughout your journey, your frictional force cannot be more than weight. Because initially your frictional force is 0, but your weight is so big. And after that, over the time, your frictional force increase until they balance the weight. Then that's it. The frictional force cannot be even more than the weight. Are you okay?
Yes.
So that's why your net force is always the weight minus frictional force. Okay? So your net force will decrease from weight all the way to 0. Okay?
Okay.
So that's why your acceleration will decrease all the way from 9.8 meter per second square to 0. That means your gradient. Then you look at this. Initially so steep here, so steep. So steep. Initially the graph here is so steep. That's why it has 9.8. Later on, the graph here is no longer steep. So that's why A equal to 0. No longer steep. Are you okay?
Yes.
And now, throughout the journey, your velocity increases from 0 to a maximum value, which is the terminal velocity. Can I? Okay, so far, are you still okay with this? With this story?
Yes.
Okay, give me a minute. Yes. Where is it? Give me a second. Okay. Now, have a look at this. This is a 4-mark question. This is a 4-mark question. Okay, let's settle this question before we call it a day. And you read through this question first. Just tell me when you have finished reading the question.
Yeah.
Can I? Wow, you see, this is a 4-mark question. That means they expect you to explain what is going on when something is falling down in the air, all right? So the first mark is you should tell me, I understand that when the object is falling down, it has 2 forces. The first one is weight, the second one is frictional force. Are you okay?
Yes.
At the beginning of the fall, the acceleration will be 9.8. Are you happy?
Yes.
Okay, so when your speed increases, your air resistance also increase, because we understand that air resistance is equal to kV. So when your V increases, your air resistance force will also increase. Are you happy?
Yes.
So now, as you keep on falling, your acceleration will decrease. Your acceleration will decrease from 9.8 all the way to 0. Are you okay?
Yes.
So finally, at the very final stage, when your air resistance is equal to the weight, finally they have no acceleration. So this is when you have reached the terminal velocity. Are you okay?
Yes.
Okay, you tell me which point you don't really understand. You read through the 5 sentences, make sure you totally understand what does each sentence mean.
I think okay.
Okay. Okay, now tell you what I understand that in this kind of question, normally it can drive a student crazy because we have 4 marks, Okay, and I have to admit that the story is so long. Am I right?
Yeah.
You have to tell me what initially wow, look at this, the gradient. Wow, initially the acceleration is 9.8. Later on, oh my goodness, the gradient is wow, simply 0. Are you okay?
Yes.
And when your velocity reach the largest value, we call it terminal velocity. So many things to tell, right? So that's why later on when you get back home, I hope you can help me to like download the recording and read this until you have memorized the story well. All right?
Okay.
Okay. Because
Okay.
the first time when I learned about this, I also found it very, very confusing at first. Okay.
Okay.
Okay. So see you along. Any question to ask me? Okay. Hang on. Later on, can you remind me to send you this thing? I want you to try. I want you to try the questions already. All right. Yeah.
Okay.
Can.
Okay.
Okay. Anything to ask me before we end the class today?
No.
Okay. So if that's the case, see you next week. Bye bye.
Bye bye.